Welcome to our panel on adapting to climate change. I want to welcome you on behalf of the university, the Earth Institute, and the International Research Institute on Climate and Society, which are our sponsors here tonight. My name is Steve Cohen. I'm Executive Director of the Earth Institute and a professor at the School of International and Public Affairs. So first I'll talk about what we're doing here, and then I'll introduce our distinguished panel. Hurricane Sandy's unprecedented impact on this region is still being felt today, months after the storm has passed. The storm resulted in a massive response effort that continues today and involved every level of government, along with an impressive outpouring of private help. It's now clear that it's going to take a long time to recover from this disaster. Anybody who looks at the South Ferry train station can tell you that that's going to be the case. Unlike the response to Katrina, though, we've seen an intense and I would say reasonably competent government response to this disaster. But the scale of the disaster and the scale of the impact means that people will continue to suffer, continue today, and until life resumes its normal rhythms in this region, people are going to complain. And those complaints need to be heard, and government has to continue to mobilize for a response. Now, as we work to transition to a fossil fuel-free economy, which is really what's going to solve this problem, and begin reversing the causes of climate change, we will still need to adapt to the impact of the climate change already underway. That's really what we're going to be talking about tonight for the most part. That does not mean we're going to abandon living near coasts. I should say, with a city with 500 miles of coastline, I don't think we're going to be heading for the hills. There's only so much room here on Morningside Heights anyway, and as near as I can tell, most of the apartments are already full. So we're going to need to continue to live on our coasts, and I think people want to do that. The risk of disaster doesn't mean that we're going to abandon our communities. I mean, it's not clear, if we look at this nationally, that any area is out of, is away from risk, whether you talk about drought in the Midwest or fires in the West, potential for other kinds of natural disasters. There is really no place to hide. We have to figure out a way to reduce and mitigate climate change and to adapt to the change that's underway. It means we have to develop more resilient homes and infrastructure and a more robust national program of emergency response and insurance. And of course, we really have to address the basic issue of climate change. However, it's not only climate change that's causing this vulnerability. The world's population continues to grow and urbanize. America's population continues to grow. That means that storms that at one point might have passed by a population now will hit that population, and that population will be bigger today than it was 50 or 100 years ago. We're also more dependent on power than we once were in our lifestyles. Many of the technologies that are central to the way we live require energy. When the electricity stops and the heat goes off and the sewage system stops working and the water system stops working, normal routines are disrupted. This means that we've got to modernize our grid, we have to modernize our infrastructure, and we have to work to build a more decentralized or distributed system of power generation and storage. But again, that's really not the subject for tonight. Tonight's panel focuses on the use of science and scientific information to help us manage our cities and facilitate our response to these kinds of emergencies. Science and technology has given us the gift of our modern way of life, but it's also given us the curse of pollution and climate change. My view is that we're going to need science and technology to help us manage our way to a sustainable and renewable economy. And tonight's panel will explore the use of scientific information to adapt to climate change. What scientific information has helped us already? What information is available but not used? What kind of scientific information do we still need to develop? So that's going to be the subject of our panel. I am really pleased to introduce to you the panel tonight. I should say that everybody has on their seats bios of everyone, so I'm not going to go through everything about our panel, except to say the first person here you're going to see is Adam Sobel, who is professor of applied physics and applied mathematics and is also a professor of Earth and Environmental Sciences and is a member of Lamont's Division of Ocean and Climate Physics. So welcome, Adam. Seated next to him is Dr. Lisa Goddard, who is the director of the International Research Institute for Climate and Society and an adjunct professor within the Department of Earth and Environmental Sciences as well. And seated all the way at the end here is Dr. Sergey Banovsky, who is the director of New York City's Mayor's Office of Long-Term Planning and Sustainability, which oversees the city's Comprehensive Sustainability Initiative, Plan NYC. He also happens to teach at the School of International Public Affairs in his spare time. And so I want to welcome the panel, and let's start off with the first question that I'd like everybody to address, which is Hurricane Sandy and the extreme weather in 2012 has reinvigorated interest in applying climate change science to urban and disaster planning. How are we currently integrating climate change data into planning for the future? What do we currently know that isn't effectively being used in those plans? So I'll start with Adam, and we'll work our way down the panel.
I haven't read all the adaptation plans that are out there, but my sense is that we're still at the beginning of actually using climate information in planning for the future, in the sense that when it comes to disasters, I mean, we have a sense, floods like Sandy, we have a sense of what the historical references are. We have flood maps, for example, that are based on the 1 in 100-year flood or some other metric like that that's based on historical events. But when it comes to larger scale climate variability, and especially anthropogenic climate change, my sense is that in some places like New York City, there's been a fair amount of effort paid to understanding what that's going to mean locally. There have been reports written about how climate change is going to affect the city. But I'm not sure if, and maybe Sergey can address this more effectively than I can, but I'm not sure if it's really been used that much in the sense of actually affecting a decision about anything that's actually, has anything actually changed yet because of a climate change projection. I'm not sure. I think there's a high awareness now, and there was before Sandy, and it's even higher now, and this city's one of the leaders in that. But whether there's real decisions have been made accounting for what we know is going to happen in the future, I don't know. And an example of that is the new FEMA flood risk maps, which what's said about them is that they don't account for sea level rise yet. Although my take on it is that maybe they sort of do, even though they're not saying it. But that's an example of where I think the information isn't yet there.
Lisa, the IRI is, one of its main purposes is actually to take climate information and bring it to decision makers. So what's your take on this question?
Well, like Adam, I'm also interested to hear what Sergey has to say about what New York is actually doing. But more broadly, in communities, there's really two types of information that are regularly being used about the future. One is just weather forecasts, so that's not quite in the climate realm. And then there's climate change projections. And so right now, I would say that for most people, most decision makers, the future is synonymous with whatever the climate change projections say. And I agree with what Adam says, that there has been a lot of awareness that's been raised from these, such as the robustness of sea level rise, at least that it globally will rise. The temperatures will get warmer, and in many parts of the world we're more likely to experience extreme events. But I think what's missing from our plans of the future is a more holistic view of climate. The fact that climate variability is a really important part of the planning, and climate varies on a lot of different time scales, and we are going to get to climate change 1 year at a time, and so we need to bring climate variability and climate change together. So I think that the things that we already know that could be better used in planning has to do with historical risks and, for example, seasonal climate forecasts, which will help us in at least our short-term planning.
Sergey, what's your take?
Thanks. Well, Steve, first of all, thanks for having us up here. What a timely topic. How you integrate really scientific forecasts with risk management and utility planning and infrastructure planning. I'd like to take a step back and just think for a second about, New York City really is a marvel of engineering. When you think about for a second the fact that we have the oldest and densest utility networks, public transport networks, and a water system that basically takes water that flows by gravity from further north and brings water down here. One of the lowest carbon footprints and generally a system that works very well. But it's our responsibility. It's the responsibility of every generation, I think, to be good caretakers of this endowment, and also to think hard about new ways of doing things as well. And I think New Yorkers are innovators. The fact that we have 530 miles of coastline is obviously a great challenge, as we saw during Sandy. I think if you look back, if you ask the question, is climate science embodied in the city government operations or the way that city government thinks about things? I think you turn back the clock back to 2006 when the mayor really convened all the city agencies to create Plan YC in 2007. And really the goal was to accommodate 1 million more people and make the city greener, more sustainable, and more resilient also. And I think really the Mayor Bloomberg really set the course there. I think it was one of the few cities really to take that deep dive really across different classes of infrastructure. In fact, I think the first city in the U.S. And I think what came of it, and I'm talking now all pre-Sandy, there's a lot to be discussed about what we're doing now in the wake of Sandy, but the Climate Change Adaptation Task Force was really brought together because of that. And what that was and still is really a group of all the major infrastructure operators from MTA to the utilities to really look at cost-benefit analysis of raising infrastructure, handling different types of climate risks. The New York City Panel on Climate Change itself has been informing and will be informing some of our capital investment decisions and cost-benefit analysis. We have reconvened that panel in the wake of Sandy. If you look at, for example, DEP's Green Infrastructure Plan, really the Plan YC philosophy is really embedded there. If you look at what Deputy Mayor Holloway and Commissioner Strickland have done there, really it's an idea to have an adaptive strategy and really build passive systems with low energy footprint to really absorb increased precipitation, and reducing sewer overflows and really doing it in a way, saving money by not just building traditional gray infrastructure only. If you look at our energy policy, has really focused on reliability, particularly after the Long Island City blackout, really looking soup to nuts at ways of making the city more interconnected with its neighbors from an energy infrastructure perspective, increasing the ability to have black start capabilities and other means to have a more resilient network, looking at cogeneration opportunities and city government assets, energy efficiency. So in my view, I think it's already been there in a way, and it's going to accelerate more now after Sandy. So the mayor has convened something called the Special Initiative on Recovery and Resilience, which is really a citywide effort right now to understand three things. One, what really happened during Sandy, really taking a deep dive across the city, looking at coastal communities affected, looking at different classes of infrastructure. So one, what happened, and quantifying it. Number two, what might happen, and this is where the New York City Panel on Climate Change is actually weighing in and revising their earlier recommendations from a couple of years ago on both chronic and extreme events. So sea level rise and wind, heat waves, and surge. So what might happen? You don't want to just fight the last war. And then third, we're going to have a set of recommendations both for policymakers and regulators and also for city agencies on what are cost-effective measures to deal with extreme weather and climate contingencies going forward.
So one of the questions I guess I'd like to turn to then is there climate science that we have that could be used that's still on the shelf that we haven't applied yet? I mean, trying to bring science into the decision-making process, as I can tell you or Sergey can tell you, is a complicated issue. But as scientists, and I'll start with you, Adam, is there some information or some analysis that you think we need to do a better job of bringing to Sergey and his colleagues?
Yeah, I think, I mean, a broader point that I think is worth making is that climate change is going to pose a lot of different risks. We know that the temperature is going to go up, precipitation patterns are going to change, have more floods and more droughts, storms are probably going to change, sea level rise is going to go up, but there's very different levels of uncertainty on those different projections. Some things we're very confident about. The temperature going up is one, and it'll go up pretty much everywhere with almost no exceptions. And we know with some uncertainty how much, but the uncertainty is bigger than we like it to be, but it's what it is, and it definitely rules out some possibilities on the low end and the high end. So I think on the one hand we have to be aware of the high risk events like Sandy, that we can't quantify the risk all that precisely. We don't know how the changes with that much precision, how much more frequent they're going to be in the future, or how much more intense. But then there's some things we are very confident about, and I don't think we're using that information as well as we could. One example that's relevant, not directly to New York City, but I think you could probably say something similar here, but this is about the Sahel region of Africa. Some of our colleagues here just did a study. This is Michaela Biasuti at Lamont and Michael Gerard at Center for Climate Change Law and a couple of their associates just did a study where they looked at the adaptation plans of countries in the Sahel region of Africa. This is West Africa, a region that's very vulnerable to drought historically and famine, and looked at the adaptation plans that the countries in that region have made as a basis for getting adaptation funding that's going to be distributed through the UN and other mechanisms. So, the question they asked was, how is climate science being used in what these countries are saying they need to do to prepare for climate change? And what they found was that the plans, by and large, were based on adapting to what's currently the biggest hazard in the current climate, which is natural variability in rainfall, creating droughts in some years. So currently, the big risk for agriculture in this region of Africa is drought. And so there's droughts every so often. Sometimes they can last for several years or even 10 years, and that can be very catastrophic. And so precipitation is the problem for agriculture, and the plans reflected that. What we know is that in the future, the temperature will be higher than anything those countries have, and this is true of worldwide, but the temperature is going to be higher than anything that's been experienced in those places. And the agricultural scientists know that temperature is going to become the dominant problem for agriculture. The crops are going to die because of heat. And the plans don't account for that because that hasn't been the problem in the past. The other thing that we know pretty well, almost as well as that, is that the precipitation, although the amount of precipitation over a season may change, but it's not going to change outside of the bounds of anything that's happened in the past, probably in that region, whereas temperature will. And the other thing that will happen is that the precipitation, although it may be comparable in amount throughout the season, on average, maybe more, it'll be less on average, but in the same range, it'll be burstier, so there'll be more high precipitation events, possibly fewer events with higher rainfall leading to more flooding, and we're pretty confident about that. Those are the two things we know with the most certainty will be different in the future. And because they're out of sample, I mean, because they isn't within the range of natural variability, the plans really didn't account for that. And so that's an example where the current climate science really isn't being used, and what the people who did this study have described it is that it could be getting ahead of the curve based on the science, but instead they're adapting to the problems of the past. And I think that if we look at, I suspect that conclusion generalizes beyond the Sahel. That just happens to be where this study was.
Lisa, what do you think? What science should we be bringing to our decision makers that we haven't?
I'd actually kind of like to follow up on some of Adam's points. I think it's relevant to what I would have said anyway. Because especially in developing countries, like in regions of the Sahel, the variability is critical. And so it's maybe not just a matter of, why aren't these countries responding to something that we are pretty sure is going to happen by the end of the 21st century. Because if their crops fail because of drought in the next 10 years, it's really not going to matter to them if it goes up 3 degrees 50 years from now. And so it's extremely important, I think, to put that information, and this is where science actually can inform things, is actually to play a more participatory role in the conversations, to have an open ear to what the issues are that people need to adapt to. I think, it's not just developing countries. Even here, Sandy, we're not adapted to the current climate. We have all sorts of issues with the current climate, and a lot of the things that Sergey was laying out actually were resiliency issues, resiliency efforts that are helping us cope with the current situation. And for a lot of places, if you can cope with the current situation and you're starting to anticipate what's going to happen in the next year, the next couple years, then you're incrementally becoming better prepared for how climate change is likely to play out. I also will acknowledge that there are plenty of decisions and plenty of infrastructure and policy decisions that absolutely need to be informed by the 50 to 100-year timescale, but not all of them, and not for all decision makers. I think that this is just a really important point to make. And so, again, I'm going to put in this plug for variability in combination with change, because climate change is a problem now, but variability is also a problem now and will also be a problem in the future.
Sergey, let me pose the question to you in a slightly different way, okay? Which is to say, what kind of science information do you know that's out there that you wish you could figure out some way to bring into the decision-making process? And I know a lot about decision-making processes too. In fact, scientists think that we actually have a rational march to decisions until there's an answer. And in fact, what happens in the policy process is we're just trying to make things less bad. And that in the process of making things less bad, we sometimes want information, but sometimes we just do not have any because sort of what you don't know can't hurt you. But let me just put the question to you. What kind of science information would you like to have?
Yeah, well, Steve, thank you for that. I think our administration is very data-driven and science-driven. We want the science to lead. I think the way I look at it, if we look at across infrastructure classes in New York City, to me it seems that the climate risks right now are not really included in the regulatory frameworks that govern energy, telecom, and other critical infrastructures. So right now there is not a clear roadmap at the regulatory level. And so we can talk about specific types of data that would be needed and which ones are there or not, but I think one of the insights, I think, is that regulators tend to look at costs rather than performance. So one of the challenges is how do you say, well, in order to mitigate this risk, should I spend $100 million, should I spend $1 billion on it? So I think you need to put it in the cost-benefit framework, and I think the climate science community and what is a very mature risk management industry at the utilities and infrastructure operators, they need to speak each other's languages. And I think that we're seeing that start to happen, but it's not quite there yet, and I think that's one of the reasons that regulators struggle to figure out exactly what price tag to put on an investment that would mitigate against some type of risk. So they want to see better confidence intervals and more of the kind of workup that they normally include in their types of analysis. So I think that's an area that we need to see more progress on.
Do you writing notes? Do you have something you want to add to that?
Yeah, I mean, was really thinking about the different question, which about what I just think those are a couple of good points. I mean, about the better confidence intervals. I mean, I think we're here in some sense. A lot of people are here anyway. Although you planned this before Sandy, some people are probably here because of Sandy, and that's so. These kind of extreme events are poster children for climate change. Whether or not a particular event has any climate change signal in it almost doesn't matter. It brings all our attention to the risks that we're facing, and so the rare events are really important. I mean, although there are a lot of different ways we'll feel climate change and climate variability. This is absolutely right about that. But even in the present climate, we are under risk for extreme events, and whether in the present or future climate, the extreme events are what are going to be the most harmful. And I think the risks of extreme events are where the climate science can stand to improve still, because there are some kinds of extreme events that our climate projections can handle reasonably well. Heat waves and droughts, the climate models are somewhat capable of doing those. Normal rainfall-driven floods, maybe. Hurricanes and tornadoes, we're still not great at. Hurricanes getting better, tornadoes a long way off before we can say what the risks are with climate change. And even in the present climate, because the rare events are sufficiently rare that we haven't been around long enough to observe the worst ones. In many places, we don't even really know, what is the 1 in 500 year storm. We don't know because we haven't had records for 500 years that are good enough. So I think, that better confidence intervals, and it's not just the scientific knowledge, but the ability to express it in the right language. I think that's true. There's a climate change science, and then there's a sort of disaster and risk management effort that are starting to communicate now. And you saw, and I think the media and public discussion after Sandy, how those were starting to get combined in a way that I think reflects in part the work done by the NPCC and Cynthia Rosenweig's group at GIS and others in bringing the government and decision makers together with the science for about a decade. I think you're starting to see that coming together, but there are different languages, and we scientists can get a little bit better at speaking that language and saying what we know, what we don't know, exactly what the uncertainties are.
Interesting factors here is that the insurance industry, the insurance business, is a huge business, and in order to operate an economy, most businesses try to insure against these kinds of catastrophes so they can continue to operate. And so in essence, you have a whole business that's based on these bets about what the future is going to look like. And so it's clear that that's a group of people that has a market for the information that we might provide. Now, I know IRI has actually been working on the issue of crop insurance for that reason. I don't know if you want to talk a little bit about that, Lisa.
Yeah, we've been doing quite a bit, actually. And this year, I would say, is a breakthrough. This year in Ethiopia was the first time ever that there's been a large-scale payout to smallholder farmers on climate-based index insurance. This is a program that IRI is involved with. It's under Oxfam. Involves Swiss Re. It also involves the National Meteorological Service in Ethiopia. But it brings in as well the local disaster agencies and credit agencies and insurance companies in the region. So there has been some drought in Ethiopia this year, and I believe over 12,000 farmers were reimbursed for their losses, over $320,000 US. And that's really unprecedented. There have been some index-based insurance payouts that have been on small pilot levels before, but this is a project that we've been involved with for some time. It started, I believe, in 2009. There were about 200 farmers involved in just one village. And now that's grown in northern Ethiopia, it's grown within Ethiopia as a whole to about 18,000 farmers in 76 villages. And now it's going to be a lot of that same sort of model is going to be transferred to Senegal. So this is something that can really help remove a lot of the risk and the poverty traps that exist in rain-fed agriculture regions.
Sergey, isn't it nice to hear about a population we don't have to worry about, farmers in New York City? To bring the question a little bit more to a somewhat higher plane, this issue of insurance and this issue of risk, and in essence, how does a city like this with 500 miles of coastline deal with these real public policy issues of how much risk do we ask the private marketplace to assume? How much does the city and state assume? And then to what extent are we really dependent on the whole national community? Yep. And how do we think about this?
Yeah, it's a huge challenge, and I think the report that I mentioned, we're going to be publishing that in May. And if you look at, for example, across infrastructure classes, in some cases, DEP is a municipal utility, so city government has jurisdiction over that. In the case of Con Edison and National Grid, those are private utilities, and so state regulators ultimately determine what the ratepayers will pay. And so if you just look across, in buildings, we have discretion over building codes, and then across measures you have different entities from federal, state to local that have jurisdiction. If you look at, for example, we had a liquid fuels problem during the hurricane. Well, that supply chain, 75% of that supply chain is outside of New York City. Refineries from Philadelphia, New Jersey, up through terminals and barges and pipelines that come ultimately here. So that's why we have, I think, a very close federal interface on this, because it's going to require, in some cases, regional solutions. But we're still working on a lot of the recommendations, particularly on coastal protection measures. Those are, we're looking, literally everything is on the table, and I think in May, it's too early for me to say exactly what conclusions that report's going to have, but I think you're going to see a very comprehensive report looking across all classes of infrastructure. So.
Adam, what's your take on this risk issue for our coastal communities in places like New York?
I don't know. I really don't know what to do about it. It's it's above my pay grade. I think it's good to put in perspective that the place, if you look at the places that flooded in Sandy and where historically there were wetlands, they're pretty much the same. And so that tells you, I mean, that's a good place to start. Now, of course, they're not going to all go back to being wetlands. It's not going to happen. I mean, the city is too far along its path for that to happen. But somehow we have to recognize the fact that water's going to get there sometime and do something about that. So the insurance could probably be more, better reflect the risks that are there. And could probably be more widely used. There are a lot of people that could have flood insurance, and businesses probably too that could have flood insurance that don't. But a lot of it's probably going to have to be engineering of some kind. Whether so you have building codes, insurance, zoning, seawalls, all these things that some have. Higher cost than others, but I think, yeah, we have to do the cost and benefit analysis, and that has to take into account what the risks are as accurately as we know them now and in the future. So one of the criticisms of seawalls, which I think is absolutely true, is that sooner or later, with enough sea level rise, they won't be effective anymore. You'll have to keep them closed all the time, and then the river will back up and it won't become unmanageable. So there's a period of time where they'd probably work, and then beyond that, they won't. And so we have to decide what time frame we're thinking on and not get complacent if we go for big engineering solutions like that.
It raises the overall issue that I remember the first time I heard about climate adaptation. People who wanted to mitigate climate change said, no, we should not even talk about climate adaptation, because that is really almost blasphemy. It means that we've given up, we've accepted defeat, and we're going to tolerate all this stuff. So we'll start with Lisa. Is that something we should really be paying attention to? Are these two irreconcilable issues? We can only deal with one at a time.
I think we absolutely need to deal with both, and I think you're sort of setting it up for that. Yeah, we're changing the planet in irreversible ways, and it's not just increasing greenhouse gases, but that's a big part of it, and that's something that we need to do something about. That's something that I think with better science throughout the sciences we could do something about. But at the same time, climate is changing, and we're already experiencing some of the effects of that. And I'll come back to the issue of climate holistically, that we need to be adapting to climate, period. The fact that New York City has experienced storms of the magnitude that Sandy brought in the past, and maybe it didn't lead to the same sort of economic and financial losses back in the 30s, I guess it was, that it did today, because there were less people and there wasn't internet and as much communication and as much wealth. But just because we have growing populations and growing infrastructure and a whole lot more demand on our planet as a whole, we need to adapt to climate. So adaptation is not a debatable topic, and it's not an either or. So just because you're adapting doesn't mean that that's a pass on doing something serious about mitigation and energy policy.
Sergey, how did it look in City Hall? I mean, this was one of the biggest emergencies that this administration had to deal with, and it was 24/7 for how long? Is this issue of climate adaptation now part of the routine of city government? Is this sort of like, you know, getting the salt ready for a snowstorm?
That's a very good question. I think that I think the answer is yes. I think it's getting there. I think you know, obviously we've had a lot to say about mitigation. The city had an obviously very ambitious plan of city government having a 30% reduction target by 2017 and citywide by 2030. We've already reduced our carbon footprint by 16% within citywide. So I think that's already a tremendous you know, achievement. We're also doing, getting back to your question about, you know, is it adaptation or mitigation? I think it's both. We launched a study last year, and we're wrapping that up right now, looking at, is it possible to actually reduce carbon emissions by 80% by 2050? And, you know, before the storm, most of our stakeholders were interested in one thing, and after the storm, we got a lot of questions on, well, shouldn't it be all about adaptation? Should we be even spending $1 on mitigation? And I think you have to look at both. And in many cases, there are actually some projects can bring you multiple benefits. When you're looking at, really, when you ask the fundamental question about how do you modernize a system, these are really relevant questions to ask, and it has to go through that process. So I think the answer is you got to do both. So.
Okay.
Yeah, I mean, about adaptation versus mitigation, I mean, the notion that talking about adaptation means we're giving up is just either, it's partly true in a sense, but it's also just reflecting reality. I mean, even if we were to radically cut carbon emissions now, beyond anything that anybody thinks is politically feasible, we've already seen some anthropogenic warming, probably a little more than half a degree, and we'll see a little bit more just because the carbon that's in the system is going to stay there for a while. So even under the most optimistic scenarios, there's some warming. More realistically, we're, you know, at the high end now of what the projections were in the last IPCC report in 2007. So we're going to see some warming, and it's just unrealistic not to recognize that. But also, I mean, the problem of, I think we have to be more realistic about the politics of it. I mean, the notion that adapting meant we were giving up on mitigation dated from a time when people still had a greater deal of optimism about the international negotiation process around climate change. I mean, we all have our hopes for it, but it hasn't done too well so far. And the problem is ultimately, it's a problem of the commons, right? We all have to reduce carbon in order for anybody to benefit. And so what we're finding is that the most effective action, the players who are able to do the most on this problem are at the local level, like here in New York, where we've seen such leadership from this administration and the city, and a few other places in the United States and around the world as well, but it's at a smaller level. And there's just nothing that regions of that size can do that by itself will make a huge dent in the carbon dioxide in the atmosphere. We can and should do it, but it's because we're being good citizens. I mean, it's not because if New York City reduces its carbon footprint by 30%, it's going to change our climate. It's going to make no difference, but we have to do it because everybody has to do it. But adaptation we can do for ourselves, and that will make a difference in life here, and so I think we have no choice.
I think it's interesting. I mean, the politics of climate is always something I'm interested in. As a public policy problem, it's really a tough one because it's created everywhere, and its impact is in the future. And our political system doesn't do well with those kinds of problems. Now, fortunately, there is the low-hanging fruit that New York City's already grabbed for, which is most of the reduction in greenhouse gases has been done through energy efficiency. It's very hard to argue that we should waste energy and spend more money on it. So the first 20 or 30% that we're getting is coming from those gains. In fact, as you were saying, the bigger gains are going to have to come from something more systemic, technological, or global. My own bet would be on technological. I don't think there's going to be a global treaty, but I don't know. Sergey, what do you think? Will there be a global treaty?
Oh, I'm not going to comment on that. I have no idea. But I mean, to go to your point, I think there are some investments like energy efficiency, which helps you not only adapt to heat waves, but also there's a value proposition for building owners to do that. So it helps you on both sides. So I agree with you on that.
Let me ask one more question to the panel before I ask for the audience to give us some questions and see what you really would like to hear about. My question is, if we had a blank slate and endless funding, What science should we be working on that would help on this issue? First I want to hear what your own groups should do and what our scientists should do, and then Sergey can tell us what would be helpful to the decision makers. So Adam, we'll start with you and then I'll ask Lisa.
Right. So I certainly think there's a lot of science to be done on extreme events, on understanding what the risks are from extreme events. I think we've only begun to do that. If you read the IPCC report, there's a lot of very quantitative information about how the temperature might change depending what carbon dioxide does. And even though we don't know the answer precisely, there's a big error bar, but we know what the error bar is. And with extreme events, it's much more qualitative statements done by very isolated groups of scientists, many of whom are, in the case of hurricanes and tornadoes, are coming out of the operational weather prediction community and aren't very well integrated into climate. And so we're just, I think, beginning to really think seriously in the last few years about the risks of extreme events. And we're never going to know, whether we're going to have a hurricane of some magnitude 10 or 100 years from now, but I think we can estimate the risks better than we have, and I think we need to do that in order to make proper cost-benefit assumptions. I don't think we're going to be able to pin down the climate sensitivity that much better than we are now. I mean, we've been working hard at saying how much warmer it's going to get. In other words, how much warmer will it be 100 years from now, given some reasonable assumptions about carbon. We know that with some uncertainty that hasn't changed in many years, so I don't think we're going to get that much better on that in the near term. But sea level rise, which is a very big one for the coastal cities, I think the thinking on sea level rise has evolved tremendously in just the last few years. And so I think there's still some hope that we could get a better handle on that. I mean, there's a very, very wide range of estimates, and at this point, we have to just sort of say, well, we should prepare for the worst, but that's not very satisfying. Could it be a foot or it could be 6 feet? I mean, there's somewhere in there in 100 years. I think we could probably do better on that. Decadal variability? I don't know. Maybe Lisa will talk about decadal variability.
What do you think we should be working on
Sure, I'll talk about decadal variability. Before I do, though, let me just say that I think that preface my answer with the development of any climate information that's going to be useful and is actually going to make a difference in people's decisions really needs to be thought about in context. What's the problem? Who are you talking to? What can they actually realistically do about it? That being said, I think that there's still a number of outstanding challenges in the climate community as a whole, and having better understanding and better tools to work with makes those context-related conversations and information development just that much easier. So just across the board in climate sciences, I would say inseparable is the need for observations, climate scale observations. Right now what we take are weather observations. We need climate observations, we need better modeling, and we need to test those things out in a predictive setting. And I think that those three things go together. You take one of those legs away from the stool and it's going to fall over. Right now the U.S. is investing in all three of these things, but I don't think at a sufficient level that we're really moving forward, and definitely not moving forward to the degree that we need to, and I think last year is a really perfect example of that. So I would hope that with sufficient investment, we would be building better climate models of higher resolution that are informed by good observations so that we're better capturing the dynamic and thermodynamic processes in the models. We need to get those physical processes right so that we actually have some confidence in what those models are telling us. And we need to come down to a much smaller resolution in order to really faithfully represent those, and even so, some processes won't be resolved. But even if we're getting the processes spot on, there will still be uncertainty in models. And so having better models is not necessarily going to ensure that we have perfectly accurate information, but what it will do is give us a much better sense of what the true uncertainty is in that information, and from that we can get a better idea of the risks. So I would advocate for really a very, I love this word holistic tonight, excuse me for using it about 50 times, but a holistic perspective on climate science, because I really think that these three pieces need to go together to produce a strong body of information.
So the way I would pose the question for you, Sergey, is that in watching the city respond to Sandy, Frankly, a lot of it was very impressive. Emergency responders, first responders were saved lots of lives. The subways were moved to higher ground. The buses were moved to higher ground. Most of the city got up and running pretty quickly. The biggest problems in the 5 boroughs, other than on the shorefront, were the electrical problems in Lower Manhattan. But in general, you have to say New York City did pretty well during this. But the way I would pose the question is, what kind of scientific information would have helped the city better prepare and better respond to what happened last year?
Well, I mean, this is a fundamental question about how science filters into the decision-making process, and I think, looking at long-term, I think, obviously billions of dollars of scarce capital are in question on whether you're going to spend them in this kind of investment or that kind of investment moving forward. And there's always a risk to over or under-investing or investing in the wrong thing. So I think this is really a key question. As you know, we've been working with FEMA on updating the new flood maps. And the last iteration of it was really the 1983 vintage map. I think the new advisories just came out recently. And if you look at, if you overlay the 100-year flood zone on any of the key pieces of infrastructure, depending on what climate science yields as far as sea level rise overlay, you're going to have a very different investment paradigm than another potentially. And so I think that whole process is incredibly important. As I look at a couple of, in the New York City panel, climate change has obviously been helping us tremendously to understand that. But I think as we move forward, there's some other areas that we probably need. As I said, there's wide confidence intervals for sea level rise. We need to understand that a little bit better. I think wind projections, those storm frequency, those will be important. A more granular quantitative analysis of heavy rainfall. So not just per day, but by hour in some cases. That impacts some systems. And we can have a list of things that I think are not necessarily easy to model. Humidity projections, that impacts how heat waves impact peak load. But I would say, as far as what kind of information the city's gotten, if you look at, for example, DEP, they have something called the Operation Support Tool, where they look at the whole system of reservoirs and where to release water and so forth. They use on a daily basis, and I don't know if you call it meteorological, more weather type forecasts or longer term. I don't know where that exact cutoff is, but that's part of the lifeblood of that agency, because they have to worry about turbidity events. They have to worry about droughts in particular, and so I think it is in many ways something that we focus on very closely. But moving forward, as I said, I think the language of the different communities from risk management and science have to come a little bit closer together. And there's a couple, I'd say, a short list of metrics that I think we need a better handle on. Some that we haven't yet produced. In other cases, we just need a more quantitative analysis to really put the probabilistic element to it that we don't have just yet.
Thank you. Okay, so I want to turn to a different part of our discussion where I'm going to entertain questions from the audience. Let me make a couple of points before we start. First of all, we're not looking for comments or debate. We have some experts here. I'd like to tap into what they have to say. So if you raise your hand, we have people with microphones who will come and recognize you. I guess we'll start in the back there. There's a question. Just tell us who you are, and if you want to say anything else about yourself, but just please ask a question. Take the microphone.
Sorry.
Thanks.
Hi, I'm Daniela. I'm a student here at Columbia College in the Sustainable Development Program. And Dr. Cohen, you introduced the panel by referencing the need to move away or to move to a fossil fuel-free economy. And also as a climate mitigation strategy, what do you or any of the panelists think about the current national movement of more than 256 schools demanding for our administrations to divest our endowments from funding the fossil fuel industry, including here at Columbia?
Okay, anybody want to take that on? Adam, you look ready?
Yeah, it's an interesting question. I was in another event here post-Sandy, the same question got asked, and I didn't answer it. Somebody else answered it, and I agreed with their answer, and the more I thought about it, the more I came to a different conclusion. My first thought was that when I first heard this raised, was that it didn't make a lot of sense to me, because, I think those of us on the left side of the political spectrum, which includes pretty much every scientist that works on this, for better or worse. I mean, let's be honest. Yeah. I mean, we may have our thoughts about who's more or less responsible for the situation that we're in, but we all are burning fossil fuels. We wouldn't be here if we weren't. So I think we're all complicit in the situation. And so my first thought when I heard about this divestiture thing was, well, that doesn't make sense, because we can't really blame the oil companies for giving us what we are paying them for, right? But actually, I've come to think about it differently. I think the issue is that the debate about climate change, which is a kind of manufactured debate at this point that's really reminiscent of the one that was about smoking in the 70s, where the tobacco companies invested a lot of money in fake studies to discredit the notion that smoking would kill you, is similar. The oil companies, some of them at least, have been involved in supporting a disinformation campaign that has not helped anything, and I think it's that justifies thinking about tactics like that. The fact that they're mining fossil fuels and selling them to us, I think we're all responsible for that, not just the oil companies, but the fact that they're creating a false debate about the science. Some people, and I think some of the energy companies, are responsible for helping to create a false debate about the science in lieu of the real debate we should be having, which is what to do about it. I mean, we know what's happening with the climate to first approximation. We just don't know what to do, and there's a legitimate political debate to be had there where different people can have different views about it, and that's the debate that we should have, and there's room for views on all sides of the political spectrum about that. But we're not entitled to the different facts on different sides of the political spectrum, and I think that's where I think efforts like this might be able to have some impact, is in changing that situation a little bit.
Let's try for another question. Over here I see someone. Okay. Yep.
Hi, my name is Roland. I work with Earth Day New York, and part of our initiative, among a lot of environmental things we do, is to promote building community gardens within inner city schools for Sergey. What sort of initiatives is New York City implementing to promote localizing food production? And the second part, food for thought, is what can we do for the future to deal with increasing temperatures and not being able to harvest previously agrarian land?
Wait, I'm sorry, what was the second part? I didn't hear that.
How can we prepare for the future? What sort of things we can do?
In what context? For what?
Localizing food production.
For localizing food. So, Steve, I confess I'm not the world's expert in food production, and I come unqualified to speak about that in any depth. But we are looking in our report at the food supply chain and resilience related to it. So everything from grocery stores to where food is stored to resilience measures around that, because you could have had an event that would have, if the moon was at a different angle, you would have had flooding that happened somewhere else potentially. And there are, a small number of food distribution networks, and so there's a question and ongoing research going on within our department, looking at exactly how food is distributed and delivered, and how we can prepare for the next event. So.
Okay, let's move on to. I see some people up here have questions.
I'm Mark. I'm in the Sustainability Management Program. This is also a question about food as well. Not so much the distribution of it from distribution centers and mass manufactured food, but what kind of research, specifically to the New York City region, is there going on about food supply? Dr. Goddard, you talked about an exciting project in Ethiopia, but we've got a lot of locally grown crops, grown in New York, New Jersey kinds of things that certainly must have been impacted by Sandy. So what kind of research is going on, or should be going on, to understand the sustainability of locally sourced food that is already being grown and distributed in the area?
I'm going to help out a little bit on this, because I actually had a group of students in the SEPA program a couple of years ago do a study for your office on how New York City gets its food and where it comes from. And what we learned was how complex our food system is. I remember talking to one of the people who runs the Green Market program in the city, and I said, why aren't there more of these? This is great. And he said, well, every farmer within 150 miles of New York City is selling everything they can grow inside the city at these green markets. That, in fact, and it still only amounts to less than 5% of our food supply here. I mean, the fact of the matter is, it may be sad to think about it, but we are now in a society where very few of us are involved in the production of food, and we're all dependent on this very complex global system of food supply. So I don't know if anybody in the panel wants to, we don't have a lot of food experts here, but anybody else want to comment before we go to another question? No? Okay, here's a, well, actually in the front here I see another question. Let's go here.
Hi, my name is Joanne O'Brien. I'm a teacher. My question is about protecting groundwater, and in particular fracking in New York State. My concern is that if we don't have enough potable fresh water, it's not going to make a heck of a lot of difference in terms of food supply. So what, if anything, is New York doing about protecting our groundwater and making sure that we have enough water to have an agricultural system?
Sergio, you want to talk about our water system?
Well, this is really a question for the state, which is looking at that right now.
But I think the broader question for us is actually our water system in New York City is not dependent on groundwater.
So our water is it comes from you know, through the aqueduct system from further north. I think regarding fracking, you know, the mayor has a public position on it, which is that there are, you know, obviously tremendous public policy benefits to natural gas switching out residual fuel oil, for example, number 6 fuel oil, which produces, you know, there's 10,000 buildings in the city that burn number 6 and 4 fuel oil. They contribute half the particulate matter emissions in the city. So there's a great value to displacing that, whether it's natural gas, biofuels, ultra low sulfur number 2. But the position also is that you know, the industry and government has to come around sensible best practices and solutions for this, you know, endowment that the region and the country has. So that's, I think we need to figure out the best way to produce that, to protect the environment. I think that's what's being looked at, particularly the Environmental Defense Fund is spending a tremendous amount of time looking at things like fugitive emissions and water emissions. And I think that's I think we're going to see a lot of progress in that regard.
Okay. Other questions over here? I see someone who's been trying to get a question in from the start.
Yeah, thank you. Rick Hirsch. I'm a CERC graduate, and I spent a lot of time on marine and fish conservation projects. I'm sure you're all busy as can be with science and data, and keep it up. And it was great to learn that the mayor's pulled New York out in front of the pack on working this issue. But my goodness, 2 days after Sandy, what a pleasure to hear the governor. I know it's a blue state, but I think he said after Irene and Sandy, I hope that the deniers get pushed into the corner they belong. Having said that, looking at Washington, from Washington to Copenhagen to Doha, zippo, nada. Do you have any theories or ideas on how we as a public or science or universities can bring at the federal level this topic more into the center?
Adam, why don't you start and then Lisa?
Yeah, I think those of us in this field are all pretty frustrated at this point. I mean, one line of argument a few years ago is we have to be better at communicating. I'm not convinced that's the case. I think that we've communicated what the problem is pretty clearly. I think there's at least two problems on the large scale. One is that in the U.S., and we've had a denialist movement that's been very well funded, and I think that's created a lot of problems that are unique to this country to some extent. The rest of the world is mostly free of that to the extent that we have it. But the other problem is just that even if we all agreed about the science, that we come back to the problem that at the international level, which is where you would need to, if you wanted to do anything on the large scale about emissions, ultimately you'd have to get everybody to do something, or at least all the big players to do something. I mean, which is us, China and India and a few others. And everybody hopes that somebody else will bear the cost of it. There's going to be costs, you know, no matter what. I mean, we had this question about fracking, and that, you know, that is an example. I mean, with going to natural gas, although in the long term it's still burning carbon, but it'd be cleaner than coal and some other sources. And so in the short term, at least, you know, we should be doing it, but it brings a potential cost to our region if they're mining the gas here. We don't know exactly how bad it is, but some of us, I think, are rightfully scared of it and don't trust that the studies that have been done thus far, they're really conclusive. But that's a not in my backyard kind of thing, but everything has costs like that. I mean, Indian Point, we get a lot of our power from nuclear, which is carbon free. It's great, right? But it scares the daylights out of me. I don't, you want to think about disaster scenarios that are scary for New York City. That's one. So I think there will be costs to whatever we do, and they're going to have to be distributed broadly. And so it's a classic game where everybody hopes somebody else will do it. And I think that's the problem at the international level. At the national level, we have a political debate that's dysfunctional, as we all know.
Lisa, do you want to add to that?
I don't think I really can add to that. I think that was a really excellent answer.
Okay. Sergey?
Well, I'm not sure how much I can opine on the federal side, but I think what we've tried to do as a city is to show that it can be done at the city level.
Yeah.
It's obviously much more efficient the larger your geographic area is. So if you have a regional carbon pool, well, it's always better to make it even bigger because you don't want to have policy leakage and other essentially dead weight losses. So I think our position is that we've done it. We can do it here, and we already have a low carbon footprint. And I think the real selling point is, in many cases, the value proposition for many of these investments makes sense. If you're, for example, leaking fugitive methane from a wastewater treatment plant, well, it makes sense. Why don't you utilize that energy productively? Why don't you loop it back in? If your building envelope is not insulating you well, it actually makes sense to make those energy efficiency investments. So I think in many cases, I think what we've shown and hope to show is that at least a big chunk of the investments that we've either supported outright or in a policy standpoint actually makes sense. And so that's the position we've taken. So.
Okay, I want to take one more question from that side, and then let me mention that after the final question, I'll make a comment or two, and then we have a lot of refreshments, and the panel is going to stay here. We're going to do informal conversations, so we can chat in small groups and one-on-one. So I hope some of you will be able to stay. So let me take one more question from way in the back there. I see somebody who's got a hand held high. Anybody over there? Okay.
Hi, good evening. My name is Andrew McCornack. I am a recent grad of the Environmental Science and Policy program, Professor Cohen's program. And a question I have, there's a room full of students and recent graduates here who are really eager to get involved in these issues in New York City and beyond. And I think something that some of us have found is there's just a real slow uptake. We all want the green economy to happen. We all want sustainability to happen, but I would love to hear from the speakers where they think young grads can really have an impact.
Okay. Anybody want to start with that?
Sure, I'll start. First of all, realize that the problem is bigger than New York City. It's a great place to be, but maybe the biggest impact you can make might be someplace else. There's just so much to do. I think being very knowledgeable, coming from a strong scientific understanding, no matter what your field of study is, having a strong grounding in the facts and information that you're bringing to the problem is really important, as opposed to letting your passion or your advocacy get the better of the conversations. I think that's the best thing going into these conversations. But I will say that the type of field that you and a lot of the people in this room, I believe, are in, it's really a frontier. It's something new, and I think it's something that a lot of agencies and companies, whether they're private companies or federal agencies, they have an interest in doing something about climate. Federal services has, and there's a range of federal services from banks to insurance companies, want to do something about climate and climate change, and they really will admit that they're very lacking in information. But because they're lacking in information in the field that you folks are in is new, to some degree you need to make your own case. You need to be out there giving them the vision of what you could do for what they want to do, because that just hasn't been articulated in a lot of cases.
I think we're really in a tremendous period right now. I think a lot of the decisions are going to be made over the next several years will determine the course of a number of sectors here for the next couple decades potentially. So I think it's an exciting time, and I was about to say, let's talk in office hours about job prospects. I think the kind of candidates we always look for, people who can write well, who can think on their feet. Particularly if you have, it's always good to have the quantitative classes to bolster that type of thinking. But there are opportunities, and it's a tough economy. But hey, we always like to take good interns who will oftentimes become employees. But I think if you look at the engineering companies, a lot of them are working on real projects involving both mitigation and adaptation around the world, and consultancies, et cetera. Anyhow, we can talk after class.
And you might want to mention that your deputy director is a graduate of the same program, Steve Caputo.
There you go. Yeah, exactly. See,
okay, let me conclude first by thanking everybody on the panel. Thank you. And let me just say that the purpose of this kind of discussion is really to, in essence, raise the level of conversation and bring science to bear and information to bear on what is sometimes a very contentious debate. The fundamental issue which people were hinting at here is, we all use this energy. We all live with it. It's part of how, the lights are on us, the microphone's on us, the internet's on, people are tweeting. This is our lifestyle. And we weren't born into this. We came to this because of things that we value and a style of life that we want to lead. And so the question of sustainability is really, how do we move from this kind of economy to the kind of economy that we're really going to have to develop in order to survive? And I think that one of the answers is we need decision makers as informed as Sergey is, and we need scientists as interested in public policy as Lisa and Adam are. And that's a lot of how we're going to solve this problem. So I'm one of those people who is actually optimistic. I think, I started studying environmental policy in 1975 when EPA was 5 years old. And I think many things have gotten better, a few things have gotten worse, but I know that in 1975 we couldn't have seen 300 people sitting here talking about climate change, and I think that's a sign of progress. Another sign of progress is that we have a lot of wine and beer in the back and other kinds of refreshments, and so I want everybody to join us and we'll hang out and talk for a while. Thanks for coming tonight.